right, so we're going to introduce our next speaker. Do you know his fun fact? I can't remember it.
His fun fact was
yes, he has written more or the only.
Yeah. So yeah, that's it. You got it.
So why'd you stop me?
Because we could say his name too. We learned that.
You learned it.
It's also written right there. Bouke.
Yeah.
See? It's written.
I would have pronounced it Bouke.
No, Bouke. Bouke.
I know, but I would have pronounced it Bouke.
Does that work too?
It both works.
See? It works. Okay. All right. His interesting fact is...
He has written, you're the only satirical Go blogger. Is that correct?
And program author. He writes satirical Go programs.
Yeah.
Awesome. Love it.
And now, Bouke.
Okay. Thank you very much. My name is Bouke van der Bijl. I work at a company called Shopify. And in my free time, I like to play around with Go and kind of push it to the limits of what's possible. And if you've been in the Go community for a while, you might have seen one of my satirical blog posts. Like one of my most popular ones is where I implemented monkey patching for Go. And I wrote a completely serious blog post, just like saying what the benefits are of monkey patching and not really letting on that it was a total joke. And you can actually download my package and use it like this. Like you can just pick a random function and replace it with your own function, like you could do in Ruby or JavaScript or something. Don't do this, it's a terrible idea. The way it works is that it disables a lot of memory protections on your binary and then overrides the beginning of a function with a jump to the other function that you've defined. Don't do this. I've even put in a license very clearly that you're not allowed to use this project. Don't use it. Still, some people used it. I even got some patches earlier this year, like someone added Windows support, which was great. I got some great feedback on my post, so that was good. Anyways, earlier this year I realized, maybe I could do something useful for the Go community, create some tools that people should actually use instead of just misleading them with tools they shouldn't use. So I created 2 projects, and they both have to do with code generation, so I'd kind of like to tell you about them. So the first problem I had is that I was creating a web app for Go, and I wanted to serve some static files. So I had things like CSS style sheets, I had JavaScript files and images and stuff, and I just wanted to serve them when you go to the page. And there were some tools that did this, like that allows you to take these files and embed them into your binary, but they didn't quite do what I wanted, or like they were hard to use, or they were missing some features. So I created a tool that's as simple as I could make it. So you just give a directory of files, and you say, create this Go file, and that's what it does. It just puts them into a file, and then you can compile it into your binary, and it gives you an easy interface to use. Like you just have a handler that you call with your request, and that's it. Then you can serve static files. So that was my first project. And the second project I want to talk to you about that I want to get into a bit more in depth is called Statictemplate. So if you've used Go for a while, you might have used templating at some point. Templating basically allows you to do this. You can define a template like the above using a lot of familiar constructs like if statements and range loops. And to your template, you provide an argument, also referred to as the dot. And your template it uses reflection to access fields on this template. So in this example, I'm iterating over a slice that I passed in, and for every element in the slice, I'm outputting a greeting with the name of the value that's provided, which will then give you a result like this. And templates are great. Like, they're very easy to get started with. You just write a file and parse it and call it. Very straightforward. It uses reflection, so it just supports any kind of data structures that you might have. But there's some downsides too, because these templates are interpreted, which means that they're not native code. Every time you execute the template, it has to interpret the template and go through the template and look at the different parts of the template to determine what to do. And this is slower than a native code implementation would be. And you also lose some type safety because it uses reflection. At compile time, you're not sure whether your template is actually safe. You might be using a names of fields that are actually not available to you, which can lead to a panic. So my idea was to take a template like the above and have the typing information that you want to use it with and generate something like the bottom. So this is a handwritten example where it has the exact same behavior as the template. It's just that it's native Go code, which is faster and more type safe than the equivalent template. So this is what I did. I created a tool that does this, and I would like to kind of walk you through of what the steps were that I had to take, and what are some of the specific challenges. So the first step I took was trying to understand what a template is. So this is how you parse a template. You can just use the built-in template package. And every template has a tree field, and the tree field contains a data structure that represents the template. And if you inspect this tree, you get something called an AST, an abstract syntax tree, which is a data structure where there's different nodes that all have a different behavior. So for my example template on the left, you have you get what's on the right, where you have things like a text node, which outputs some text. You have a range node, which has the same behavior as a range loop in Go, et cetera, et cetera. And the way I created this image on the right here is that I took a great tool called AST Explorer, which you might have seen if you've done front-end development. It allows you to put in different programming languages like CSS or JavaScript. And what it does is it parses your code and then generates a nice clickable interface for you to go through the template. And then I took Go4.js, which can take Go code and translate it to JavaScript, which I then hooked up to the AST Explorer. So I could put in my Go template and then look through it. So when I put my tree structure next to my handwritten Go code, I realized that there's a very clear mapping from AST nodes to Go code. So if you see at the top, there's a text node, which is basically the same thing as a write string call. You have a range node, which is the same thing as a for range loop. So what I realized I had to do was I had to go through the source code of the Go template package and look at all the different nodes that were defined and kind of think about what the equivalent Go code would be that would have the same behavior, and how I would generate that same Go code. And some of them were very straightforward. There's the text node, which just outputs the text, and for that I just had to do generate a write string call with the text as a constant. But some were a bit more complicated. So this template here, what it does is it outputs the value of the name field, and this is the information you get. So you just get an identifier. But the problem is that this template can actually have different behavior depending on the data structure that's passed in. So there's actually two ways that you could translate this code. So if you have the name, then what the Go template interpreter does is it looks at this field, and if it's a variable, it just outputs the value. But if it's a method, it actually does a function call. So I realized what I had to do was I had to analyze the type to determine which of these two I had to generate at compile time, and I couldn't do that at runtime because I couldn't use reflection. So basically I had this information. I knew what the package was of the type, I knew the name of the type, and I knew the name of the field. And using this information, I had to determine what is this? Is this a method or is this a variable? And thankfully, everything you need for this is actually provided to you by Go, either by a standard library package or by an official package that's part of the extended standard library. The most useful of which is called Loader. And what Loader allows you to do is you specify a package that you want to load. So in my example, there's my example package. And then what you do is you call load. And load does basically the same thing as the Go compiler, where it will load your package, it will parse the files, it looks at the dependencies of your package, and then loads them. And it does this recursively until it has all the typing information that's required. So once this loading is done, you can get back a reference to your package, which you can then use to do analysis on. So you can look at what's defined in the package, and you can do certain queries on it. So then what I had to do was I had to use the eval function in the built-in types package. And what eval allows you to do is you provide with it an expression. So in my case, I have the person expression that I wanted to evaluate. And what it will tell you is what the type is of that expression. So what this will do is it will look at the package. In the context of the package, what does person refer to? So in my example, then I get back a reference to my person structure, which I can then do more analysis on. And I was very surprised that there's actually a method that's exactly what I needed, lookup field or method, to look up whether something is a field or a method. So that you call with a field or method name on your type. So here I'm specifying this is the type that I want you to look up this field or method on, and this is the name. And this function will give you back an object that it returns an interface which can be multiple different things, which you can then do a type switch on. So here I'm doing a type switch, and if it's a variable, so if it's just a regular field, I can emit a dot with the name of the field, so I can just do a access on that field. If it's a method, I do a function call. And then I also have to do a different thing to return the type information of the field or the method. So in the case of if it's a field, I can just return the type of that field. If it's a method, I have to analyze the signature of that function and then look at what the return value is. And the reason I need to do that is because you can have a template like this. So if I do .parent.name, I need to know what the type is of parent to know what the type of name is going to be. So I need to propagate this type information through and have all this type information available to my code generator. Then another challenge was functions. So if you have something like this, like in this example, I'm just looking up the length of a passed-in argument. So it would look at a slice to determine what the length is, and then it would output the length. But I had to figure out how to translate this code, because like, where is this length function defined? Like, how does it work? There's different kinds of functions. How do I know what I can translate? So again, I went through the source code of the template package, and I found a list of all the built-in functions. So here, there's a couple of familiar ones like sprintf, but the majority of them are actually private functions, which you can just call, and I needed to call these to be able to use them. So basically what I had to do was I had to figure out a way to call a private function, because I could just copy over these private functions and make them public, but that will mean like maintaining all that code, and maybe if there's a new Go version, it slightly changes, and I didn't want to bother with that, so I wanted to figure out a way to call a private function. And I actually found out that this is built into Go. It's not like, you shouldn't do this probably, but it's possible. So if you look at the top, I use a directive called link name. And what link name allows you to do is it allows you to define a function without a function body. So here I have my &_private. And then what it allows you to do is to say, take this function and at link time, link it to this other function in this other package, public or private, doesn't matter. So what I'm saying here is like link this function to the text/template and function. And that works. It works if you import unsafe and you also have to create an empty assembly file in the same directory. So don't do this, but maybe do this. Like, think about it. And I also found out that you can't do this with a public function, so I had to kind of re-export it with another function. But anyways, after that, I could create my own version of this function map with all the same functions, just public. So now I could translate this code. I have my template, and I could import my package with all the functions defined. and then do a function call. So Go actually has two template packages built in. There's the text template, and then there's HTML template. An HTML template is really cool because it actually does analysis of your template to look for potentials for security vulnerabilities and then automatically applies filters to them. So in this example, I'm putting a value into a property of this HTML tag. And when you use this template with the HTML package, it will automatically insert the right escaping function depending on the context of this value. And so I wanted to support this, of course. So basically, I ended up doing the same thing again. I linked a private function into my package, and this function looks at the template and escapes it and stuff, and then I could support it. So I just had to export all of those hidden functions into my package and escape the template before I generate the code, and then I could support this function. So let's talk about the development experience, because for me it was important that if people adopt my package, it doesn't mean that their development experience is going to be worse. The good thing about Go templates is that you can set up your program so that you can load your site, make a change to your template, save it, and then just reload without having to kill your server, recompile, and start it again, which just adds a lot of time. And I didn't want it to be so that people had to do that and also do a Go generate to make it all work and maybe forget that, and you don't want that. So what I ended up doing was actually adding support for generating two files. Go has a great feature built in called build tags, and what a build tag allows you to do is to basically say only or don't compile this file if a certain tag is specified. So if you call go build with the tags flag, you can say, so you can toggle all certain flags. In this case, I'm toggling the def flag. And when the def flag is specified, it will use the version on the right of my file. And if you don't specify it, it will use the version on the left of my file. So the left version will do the thing where it generates all the Go code, which will need recompiling if you make a change. But the right version, it just uses the built-in template package and reloads the template every time you use them. So this will basically give you the best of both worlds. It will keep the development experience fast and allow you to iterate fast. But then when it comes to actually building the production binary, it will do the static type checking because it's using all the field accesses, and it will give you the speed benefits. So I wanted to give you kind of an idea of the speed benefits. I made a super unscientific benchmark where I created a blog with 100 posts, exercising some of the different features, like multiple template files and if statements and range loops, and just to give a general idea of what you could expect. So in my example, my static version is actually more than twice as fast as the dynamic version. But of course, this will depend on your specific application and what you're doing with it. So I would like to invite you to try it out. You can go get the tool and run it like this. And basically all you need to specify is to give it your templates and then give it a flag which specifies generate a function called, in this example, generate a function called hello from the greeting template and using this as the argument. And it will then automatically do the type inspection and all that stuff and generate a template file for you. And my tool supports all of, or at least the intention is to support all of the same functions and as the built-in template package. So if something is missing, make an issue and then I'll fix it. So thank you very much for listening. And you can find my other satirical blog posts on my blog, by the way, or send me feedback on my Twitter. So thank you very much. Do we have time for questions?
Oh yeah, we have time for a few questions, and we have a few questions.
Yeah.
It's nice work. Can you avoid
I can't repeat that, but
Okay, let me try again. So right now you're sort of using a hack to get into these private functions in the original template package, but it seems to me that if you were to copy them, you could then generate code that calls the right one for the type and then avoid essentially a reflection-based length function or whatever.
Yeah. Yeah, so just for context for other people, like the functions that are in the original template package, they just take in interfaces, so it will use reflection to determine how to, what to do. And like this is totally possible. I actually use the typing information for some optimizations in different parts of my code. So for example, if a function call returns a string, it knows it can use the write string function instead of the fprint function when outputting to a writer. And yeah, other optimizations like this are possible too. Yeah.
All right, Fatih?
Yeah. So you said there's an AST that the text template package uses. Are you generating a Go AST first and then using the Go printer to generate it, or are you just generating the Go source code yourself, like depending on the text AST?
I'll repeat. He said there's a template AST and there's a Go one. He said, are you, well, I don't know if I can do this right, generating the Go AST, or are you just generating the code directly?
I am generating code directly. I just found it easier, and then just run it through the Go formatter before I output it. Yeah.
All right, we have time for one more if we have. All right, thank you.
Okay, thank you very much.